All right, let's get started. So, it's coming rapidly to an end, right? So today is the last lecture that I'm going to the last presentation that's going to be on mechanisms. Okay. After that, I was debating whether I should do another one or not, but I won't, and I'll tell you why later on. Uh, so the last 2 weeks of the course is going to be something I already told you brand new. There's nothing to do with this. Okay. But these are ultimately all related. I mean, you do mechanism design because you want to find the acceleration of a part so that you can put it in an FEA package, okay, to get the stresses and things like that. So these are ultimately related, but the way we do it in this course, these are disjoint topics, kind of. All right. Uh, there was a question about homework number 6, the first one that I was not here, and I want to go back to that. Well, first of all, I'm going to be talking about rules instead of formulas, where we put physics into the problem. We'll do that later. But and that requires a little bit of C programming. I mean, I'm not an expert C programmer. Neither you are. Neither are you. I don't know. Maybe you are. But these are not complicated things. Okay, we're not talking about a code that's 50 lines long. You'll see it. You'll see it. But there was a question about this 4-bar linkage. You did this in assignment 6, and somewhere in the video solution, I refer to a Grashof condition. I said that this meets the Grashof condition. A Grashof 4-bar linkage. This is a 4-bar linkage. And if you see it, you say, well, what is the fourth one? Well, the fourth one is the ground. The fourth one is this ground. For example, this actually is what you see on the right-hand side. But this bottom one is fixed. That's why there's no reason to actually draw it here. A 4-bar linkage meets the Grashof condition if there is at least one member that goes 360 degrees completely. And why do we want that? Take the wiper blade of a car, a bus, a car. There is the wiper that goes like that, it rocks, but there is one of these linkages which is attached to a motor. The motor turns continuously, so that 4-bar linkage must be Grashof, otherwise the motor will not be able to turn, make the wiper rock. Okay, so that is important. That is important, an important concept. And there is a condition that you need for that. The sum of the smallest link plus the longest link must be less than or equal to the sum of the other two. If you don't meet that condition, there is no mechanism, there is no linkage that goes exactly 360 degrees. Okay, it stops before that. So that's what the Grashof mechanism is. Okay, any questions about this? All right. Now, the stuff that we're going to do today is the first part of it is nothing new, a very simple problem. You have a block which is accelerating down a ramp, down a track. That's the very first problem that we did. Okay. It can go at a constant velocity, it can go at acceleration, etc. The one that we did was actually constant acceleration, but here I'm going to do it with a constant velocity, which means acceleration is 0. And then on top of that, there is a propeller. We can see that. I'll make it look like a propeller. Imagine that this is a helicopter or something like that, helicopter blade that also turns. Now, we know how to do this problem, and there is no, I mean, if you have this problem to do on the test, that's a giveaway. Okay, so simple. But I want to do this problem with the velocity not constant. If the velocity is constant, there is no problem. You can do that. Put it in the formula. 5 inches per second divided by 1 second times time. No problem. But if the velocity is not constant, that formula, add a formula, does not work. You have to write a few lines of code. And you can see why, because it said if time is less than 4, velocity is 2. If time is less than 6, or between 4 and 6, velocity is 0. If time is bigger than 6, velocity is actually negative, so it goes backwards. Same thing with the propeller. You can have a situation like that. propeller also is not going at a constant speed. It could, but I want to do one that doesn't go at a constant speed. And finally, you put both of them together. This is the problem that you're trying to modify. So you do have to write a few lines, and it's only a few lines, okay? Lines of code. I think here is about 6, 7 lines, something like that. And there is, I mean, if you have done programming, you know, you understand what this thing does when we do the problem. Okay, so let's go back here. Oh yeah, I forgot to tell you. Actually, there was a comment here. What about the missing dimensions? In this problem or in this problem, I didn't give you, for example, the whole radius. I didn't tell you how much this had to be padded because those are irrelevant as far as the mechanism is concerned. The only thing that's important is that center to center length. Center to center, center to center, center to center. So let me make it very clear. If on the exam there's a problem like that, and somebody asks me, well, what's the radius of that? I want to make it, but I can't make it if I don't know that radius. I will walk away, okay? Because the radius of that whole circle, pin, etc., is totally irrelevant. What is important is center to center. As a matter of fact, you don't even have to make it like that. You can make it rectangle, 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 rectangle. As long as when they're connected together, the length of the rectangle or those numbers is going to be the same information. Okay, so the same thing here as far as this problem is concerned. I'm not going to even bother telling you what the radius of that hole is or the pin is because it's totally irrelevant. Okay. Actually, for this problem, all dimensions are irrelevant. Yeah. Now, obviously, if you want to plot, for example, hypothetically, the velocity of a point on the tip of the propeller, you better know what this radius is. Otherwise, you can't plot it. Okay, so just be aware of that fact. All right. Are there any questions? Okay, so let's go ahead and do it. So file, new, product. Okay, immediately save. Let me go to assembly design. I don't like to work in this environment. So file, save management, save as, desktop, new folder, my last Mac. One, group one. Okay. All right. I'm going to make a track 11 inches long, just so that I have an idea how these things are as far as the size goes. So insert a new part in there, and I'm going to call this thing track. Right-click properties, track, and track. And I hope you realize by this time why I'm fussy about giving instance name. Because if I want to debug my joints later on, and if you don't give it meaningful name, it says prismatic joint between part 1.1 and 1.2, or something like that. But if I call it track, it says prismatic joint between the block and the track. Without changing the instance name, that's not going to happen. Well, as long as you can do it, no problem. Up to you. Okay, let's make it. On this plane, I will sketch a rectangle. Dimensions totally irrelevant. So it's very, very possible that I give a problem like that and I say you make it your own dimension and do something with it. Okay. So, let me let's exit and pad it. I'll make it 11 inches long for a reason that I want to have an idea. You always want to have an idea how big these things are. Okay. That takes care of this. And then insert the block. Insert new part in there. Always say no, unless you want to say yes for whatever reason. Properties. This is going to be block and block. Let's make it. Double click on a convenient plane, on that horizontal plane. I will sketch something that is 1 by 1 by 1. Totally irrelevant, but I'll make it 1 by 1 by 1. Okay. So to draw a rectangle here, we'll fix it in a minute. 1 inch by 1 inch, and I'm going to pad it up by 1 inch. Again, irrelevant. 1 inch. Okay, good. And on top of it, I'm going to make a little hole because I want to make something that looks like a propeller and insert it in there. All I need to do is really draw a rectangle and put the edge of a rectangle along with the edge of one of the edges of the block. It becomes a revolute joint, but I'd rather do it better. So on this face, on that top face, I will sketch a circle. You can center it if you want. You don't have to if you don't want to. Fine. The propeller, the shaft of the propeller is going to go into this thing. I hope this is recording. So let's go up there and save everything. And you know why. If the system crashes, I haven't saved anything except for the product, initial product. All these two parts are going to be gone. There's nothing in it. Okay, so insert a new part in there. And I'm going to call it prop. Right-click properties, prop, and prop. Okay, let's make it. All right. So I find this thing convenient. On that face, I will sketch something that looks like a propeller. Or a blade, I don't know, something like that. And let me make these things concentric. Excuse me. This control, that, will make it concentric. Okay, I'm perfectly happy with that. And to minimize my work, I'm going to project this circle into it, exit, and I'm going to pad it. Now, if I pad, I will get a hole in that propeller. As far as the mechanism is concerned, it doesn't matter. But if you insist on making a propeller, because I told you why, if your problem doesn't work, at least make it the way I asked you to do. If the problem doesn't work, you couldn't finish it, then give me a reason to give you some marks. Okay, at least you make your stuff right. Okay, so can you suggest one way of doing this thing? If I want to make a shaft there instead of a hole, what would I do? What icon do I use? Yes, multipad. Yes, yes. Okay, so it tells you there is 3 curves here. This is the hole. If I want to make it actually a shaft, so let me make this thing, I don't know, maybe 0.5. And this one is the thing, the propeller itself. So let's make it 1. Whoa, wait. Let me clean this up. Okay, hang in there. Let me, it should be, let's make it 0.4. Is that the first one? Yeah, okay. Good. So, can I do the problem like that? Of course. But I'm going to turn it around. Okay, so that it actually goes into that hole. So, before we do that, we're going to save everything. Good. And now we're going to go to impose assembly constraints, because if you don't, there are no assembly constraints. When you go and use the magic wand, it says, hey, what do you want me to do? There's nothing there. Okay, so you have to create those joints manually or have to go back and put the constraints in the assembly design. So let's do that. So let's anchor the track, okay? Anchor the track, and coincidence between this edge. Actually, let me do it like that. Coincidence between this edge and that edge, because I'm lazy. Otherwise, I have to delete that constraint. These two edges, and coincidence between, for example, you can do this face and that face, or the bottom faces. Doesn't matter. It's going to give you prismatic joint anyways. Either way. Let's see if it looks good. Yep. The only thing is that this didn't start there. If I insist on starting at the very back, then I put a constraint there and then delete it right away or deactivate it. Okay, because I don't want it to start there. I want it to start way at the end. So coincidence between, for example, this edge and that edge. Update. Good. And now, if you, in case you ever need that constraint, let me deactivate it. If you don't, then this is going to become a rigid joint. Think about it. The block is supposed to travel on the track, and you're saying that, hey, this is and that are coincident. It's not going to go anywhere. It's going to become a rigid joint. Anyway, not anymore because I deactivated that. And then coincidence between this axis and that axis, and coincidence between this plane and that plane. Probably we have to flip them. Yeah, you have a feeling for these things now, because when they're flipped means these two faces are going to be mating, okay? Otherwise, the same direction. In the event that you insist to this thing to be horizontal or vertical, you have to do it. I'm not going to worry about that. That really defeats the purpose of this tutorial. All right, so let's save everything. We're going to go to the digital mockup, DMU kinematics, get the magic wand out, new mechanism, and by this time in the course, you should know that you're going to get two joints, a revolute joint and a prismatic joint. Okay, let's check it. Just do not be disappointed if you have some other joints, because it could be that you did something. For example, if I had done the edge to edge, I had not deleted it, I would also get a rigid joint that I have to get rid of it. But this is fine. Now, if I want to put physics into this, it's very simple. We're going to say, for example, the velocity of the block or the position of it is equal to velocity, 2 inches per second, 1 inch per second, times time. Okay? And the same thing with the excuse me, with the propeller. You know how to do that. For example, let's try. Here, I'm going to double click on this. I'll make it angle driven. So, by the way, this blue arrow means that it's going to go clockwise. If these things matter to you, you have to choose the right direction. But it doesn't matter to me in this problem. Okay. This arrow means that it's going to go counterclockwise. But that's fine. 0. Okay, good. And this one, double click on it. It's going to be length driven. And I'm going to go between 0 and 10 inches, right? There must be an arrow somewhere. Oh, right there. You see that? There. I don't want it to go that way. I want it to go in the other direction. So I'm going to flip this. Okay, good. Needless to say that the mechanism can be simulated manually. And what that means is that if you try to be in charge, simulation with command, there is going to be two sliding bars. Because you said that this is length driven, the other one is angle driven. You are controlling it, then you were a slider. Okay, so there we are. Where is it? Oops. Okay, there is the propeller. there is the block, etc. Now, if these things don't work, you're going to have a hard time finishing the problem. In fact, I could have checked that in the assembly design with that little checkbox. Remember the checkbox, respect the assembly constraints on? Okay, without having joined, if the assembly constraints are respected, then you can get this kind of a motion depending on. Okay, so we want to put some physics into it. All right, here are the commands. Double click on this. Actually, how do you put the physics into this? I want to say the block goes 2 inches per second, etc. Let me see. Okay, go ahead. Yeah, f of x, exactly. So you go there. Right there, knowledge. Click on the mechanism. There's only 3 things important in this mechanism. That command, the length and the angle, and the time. So it's no wonder that all other dimensions are irrelevant. You can see that. So for example, I'm going to say the length. Let's do the length first. Length, add a formula equal to, let's say 2 inches, 2 inches in 1 second, 2 inches per second. You know how to do that. You're going to say this is equal to 2 inch divided by 1 second, right? You can do that. Multiplied by time. Multiplied by time. You can also say, if you want, 2 inch underscore second. It does the same thing. If you don't want to divide by 1 second, you can say inch underscore s. What can I do? That's it is. So if you don't want 2 inch, write it like that. If you put underscore s, it's the same thing. And if it doesn't work, go back and change it. Divide it by 1 second. And then times time, right there. Okay, say okay. And this one, let's make it 360 RPM. 60 is my favorite number, 60, 120, and things like that, because 60 RPM is 1 round in 1 second, which means 360 degrees in 1 second. It's very easy. Okay. No, wait a minute. 60 RPM is 1 round in 1 minute. 1 round. Wait a minute. Hang in. 60 RPM is 60 rounds in 1 minute. And therefore, 1 round in 1 second. Agree? Okay, so that's good. 360 degrees in 1 second. So I say add a formula. I can put 360 degrees underscore s, or divided by 1s. It really doesn't matter. Times times time. Okay. Good. All right. So save everything. All right. I'm still not solving the problem that I want. The problem that I want is this. I'm just using constant velocity right now. Okay? We'll come back and do this later on. Okay, so we go to simulation with laws. I'll make it 10 seconds. So I don't remember what I put for velocity, but whether I put a 1 or a 2. Actually, you can see it in the tree. If you look in the tree, these laws that you created, 2. Okay, 2 inches per second. So that means this being 10 inches is going to take only 5 seconds to reach the end. Okay, I'll leave it like that. I'll leave it as 10. Okay, 10 seconds. Is that clear? See, I put 2 inches per second, and this whole thing was 10 inches long. So it takes 5 seconds to reach the end. But I'll leave it as 10 so that it goes off the track, basically. But that's okay. All right, now, let me activate the sensor. Notice that I did not create any sensor. I did not create any sensor. I could have. But in spite of that, it allows you to plot those things. These are the commands. One of them is the length, the other one is the angle. Although I didn't specify any sensor, I can still plot those. So let me say yes and yes. Move it down. Let me get rid of the tree. F3. Oops. Okay. I don't know. Okay, let's play it. Oops. Come on. Okay. It reaches there. And I can go and graph these two commands. Both of them are going to be lines, linear functions, because velocity is constant. Position is going to be velocity times time, a straight line. Angular velocity is constant. The angle is going to be constant times t. Okay, so both of these, if I plot it, is going to get this. So this is an easy way for us to check your formulas, by the way. We plot this, it better be what we expect. Are there any questions? You already knew that. Nothing new. You've done this thing many, many times. So I want to close this and remember, and this is being recorded, if we ask you to submit something along with your other files for this problem, you screen capture these and give us only the thing we asked you to submit. I don't want 10 plots here because you don't know how to do it. Basically, you say, give me everything, all the sensors. So you're not going to do that. You have to submit whatever we asked you to do. Screen capture, save it in the Word document, save it, and put it in your folder that you have. Same arrangement as the midterm. Now, I want to show you a different way of doing this thing. You might say, well, why should I learn a different way? I can do it if I can do it like this without an issue. Because this other way will allow you to solve those complicated problems. Okay? So, let me rewind, and let me close, and let me close. All right. So, I want to do the same thing. Do the same thing. Constant velocity. Still not that complicated expression. We're going to do that later. But not with formula. Because that's a requirement to do more complicated problems. I don't have to do it for this problem this way, with this thing that I'm going to show you. But when the problem becomes complicated, such as the one that I showed you, you have no choice. You can't do it with formula, like what we did here. And on purpose, I'm not going to delete these. I'm going to leave them here. Okay? I'm going to leave them here. So, this is new. You go to start to knowledgeware, start knowledgeware, knowledge advisor. The very first one. That's the only thing we're going to do in this course. Everything changes. All the icons change. And this, as soon as you go there, this, one of the toolbars that I have is called reactive features. I have no clue whoever came up with this name, why they came up with something dumb like that. Why would you call it reactive feature? I don't know. But it's very easy to find out. Just if you look at the second icon to the right, and if you have a good eyesight, you see that there is something that says if X braces Y. Programming. So you want to write a program. You click on it. This is called the rule editor. So it says, okay, what do you want to call the rule? I can call it my rule. Rule number 1. Basically, you may have several rules, so give it a meaningful name. In this case, not an issue because and the creation time, by who it was created, etc. And you click on it, and you get this, which is the rule editor dialog box. Now, first of all, this is where you write your code. It's not limited to this. You can scroll down. You can write a line of code which is 1,000 lines, a code that's 1,000 lines long. You're not restricted to this. But on the right side, it's all the garbage in this problem. All the dimensions, all the constraints. I don't want that. I just want my mechanism. Look, if I click on the mechanism here, just like I did before, it only gives you three things: length, angle, and time. Okay, so here's what I'm going to do. I'm on the first line, by the way. You can delete this, you can change it. This // means comment. Okay, I'll go to the next line. I don't want to remove that. I'll just leave it the way it is. But // comment doesn't take in. So I want to say the length equal to. Okay. By the way, I don't need it for this problem. However, notice that there are, if you select the keyword here, you get the stuff that you use in programming. Because if you don't remember whether if is big I, little f, or little I, little f, or else is this or that, it happens, it's right there. I don't need it here because just over a 10-second period, it's all the same. But I will need that if statement later on for the more complicated problem. Okay, now here is what I advise you to do. What I suggest is put everything in here, although you might get away with it in this problem, which is very simple, in braces. Okay, because remember that name, the icon says if parentheses x, comma, braces y. Okay, so for example, if you want to say if x is between 4 and 5, these things go in braces, okay, because you may want to add something to it, and y is between, and x is between this and this. So my suggestion is that put it in braces. You have to do that with a more complicated problem anyway. I put the braces here, the braces. Did I put it? Not yet. Up there. Equal to 2 inch per second, 2 inch per second, 2 inch underscore second, or 2 inch divided by 1 second, times time. Now time, if you can't find it, go search in your list. Wait a minute. Keywords, dictionary, parameters. Oh yeah, time, parameters, time. Yeah, it's the same thing that you did for formula, except that you're writing it as a line of code now. Next line, angle. Let me click on my mechanism so that I got them all. Hang in there. Okay, so I can select it from here. This was for the prismatic one, for the Revolut one. Oh my God, what did I do? Let me get rid of this. I can't see. I don't understand why I'm not getting my. You know what? I have to. Yeah. Oh, all you said. Yes, thank you. If this happened to me on the test, I'll close this thing and do it again. Because I was wandering around with these and I kind of lost track of what I did. Good. So the angle. Okay, the angle equal to. I think we said 360 degrees per second, right? 360 DEG underscore S, which is the same as 1 over S, times time. Okay, good. And I'm going to close the braces because when you write programs, you miss a parentheses, you miss a braces and things like that, you get syntax error. Basically, that's what it is, okay? So if I don't close the braces, it's going to complain. I know it will. So I'm going to close it. But you should be prepared for things like this. You have to basically debug your program. And say, okay, it's very easy to make mistakes when you write a code. And already you can see that. So what's the issue here? It says braces. Do you see? It's already complaining about these braces. Syntax line 3. Okay. Oh no, there's a multiplication here. Let me say yes or no, and then we're going to fix it later on. That didn't do anything, so we say no. It closed that. So basically, my law is all scrapped. Yeah. Oh my God. Okay. All right. So let's do it. Okay. So rule number 2, because rule number 1 was already done. Fine. Okay. So let's do it. Yeah. Mechanism. Now you can see why I don't want to do more than one problem. Because if I do 50 problems for you, and if I did it perfect without any mistakes, and you don't do it yourself, the 51st problem you're going to get stuck. I mean, here I'm running into all kinds of problems myself. That's why you have to see how things are done. You go work it out. You go work it out based on your own rules and things like that. Okay, so let's try it again. Braces. Let's put braces here. Okay, and here is the length equal to 2" underscore s times time. Next line, your angle equal to 360 DEG underscore s times time. Okay, close the braces. If you don't, it's going to complain. What? Can I do the same thing here? It's the same message, right? What does syntax error line 2 over here? Braces. Okay. You know what I'm going to do? I'm going to say yes. I'm going to take away those braces. Okay. So I'm going to take away those braces. Let's see what happens then. There was a quotation here that I deleted also. Now I'm going to take the braces. Let's see if it complains. Yeah. Oh, okay. So let me delete this. Thank you. Let me put the angle. Oh, okay, no problem. Let's get rid of this. Angle. Okay, angle equal to 360 degrees DEG underscore S times time. And I didn't put any braces. I don't think that was an issue, but we'll find out. Parameters must end with do you see anything obvious there? Where? This is a quotation. Second one. This is not an apostrophe, you're saying? mechanism. What is this? This is a quotation, isn't it? First line. You see an obvious error there. Where is it? Can you tell me? This one, right? Really? Looks okay, okay, okay. Okay, so which one is this? So is that right? I'm gonna delete this. I'm gonna delete this, okay? You're saying that there is something wrong there, correct? Okay, I'm gonna delete this. Okay, next line. Next line, I'm gonna use the length, right? So it's gonna be length. Are we good? Equal to. I told you it was better if I deleted this thing and did it again. Equal to 2" underscore s times time. Yeah, and I don't have any braces. Let's try it. Hopefully we don't get an error message. And then we put the braces. Let's see if it gives us the error message. I don't think it will. But anyway. All right. No, 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 no. I did it on purpose. I did this thing on purpose. If you read this thing, it says, hey, you already gave me some formulas. Remember I said I can delete those formulas? If I don't, then it's going to come back and say, hey, you already have two formulas there. Now you're telling me something else. Would you like me to deactivate those? If I had deleted those formulas, I would not have gotten this message. And notice that when I say yes, these two are deactivated. There was nothing wrong with it. It's just that I did not delete those formulas. Okay? And now it says, you're telling me something else now. Should I deactivate those? And obviously I said yes, although they were the same thing. Are we good? Okay. So let me run this thing. So you go back to the DMU kinematics, and then simulation with laws. Nothing fancy. We're going to get the same graph. Okay? Graph. Same graph. Now, why did I make it my life so miserable? Struggling with this thing for the last 10 minutes. Because if you have curves like this, you have no choice. You have to write if statements, else, and finally whatever it is. So let me go and make one of these. I'm not going to make both of them. Oh, actually, you make both of them. How about that? Okay, so this has to be in front of us. So between 0 and 4 seconds, this is 2 inches per second, and this one is, I'm going to use these numbers, okay, 108 degrees per second. Now, notice that these breakpoints are the same, 4 and 6, 4 and 6. Because they are the same, it is very easy for me to put both of these in the same room. If these breakpoints were different, it's easier if you make two rules. One for the length, the other one for the angle. But if the breakpoints are the same, I can put them both in the same room. Okay? It's easier. I could have done this problem with two rules. One for the one for the length, the other one for the angle. But I didn't put them in the same thing. So let's go ahead here. Now, there is a big catch here. You've got to pay attention to this, please. Okay, let's get rid of this. Let's rewind. Get rid of this. And close. So, we go here. We go to this. Okay? I'm going to delete all of these. So I'm going to say if time is less than 4 seconds. If, and if you don't remember how the keywords work, there it is. If time, now time is this. If time is less than 4 S, not 4. 4S must make sense. You can't say time less than 4. For what? Apples? Hours? So 4S. If time is less than 4S, okay, then braces, because I want to write two things, one for the length, one for the angle. Okay, so braces. Here you have no choice but to put the braces there. Believe me, even in the other one, if you put braces there, it would work. Our problem was something else, that apostrophe, whatever. Parameter, all right. Let's start with the length. Okay, how about that? If time is less than 4 seconds, length is equal to, if you look at this diagram, it says 2 inches per second times time. So it's going to be 2 inch underscore second times time. Return. And angle is equal to, what do we have here? 180 degrees per second times time. 180 degrees per second times time. 180 degrees underscore S times time. Where's the time? Right there. Close the braces. Close the braces. Else. Where's else? Keywords, right there. Else if, yeah? Come on. Oh, went on the wrong line. Else if. There. Too many of them. Else if. Now, else if time is less than 6, because if you look at it here, it was 6. Okay? 6. So, else if time is less than 6 seconds, braces. Now, velocity position is going to be what it was. In other words, during that time, during this time, position does not change, and it happens to be what is that? Is it 8? 8 inches, right? 8 inches, right there. During that time, position stays the same. Velocity is 0, basically. Okay, if you want your field. So let's write it. Braces. That position is equal to 8 inches. Next line, and the angle of the propeller is 720. Angle of the propeller is 720. During that time, 720. That stays the same. So right there, angle equal to 720 degrees. You got to be careful about these things. They're not hard, but they have to be consistent. Close the braces. Else, why does it go there? Else. Okay. Else, all you need to do, I'm pretty sure you write down parentheses, the time, not the time, but the position. Just be careful here. Parameters, position, not braces, position is equal to 8 minus whatever that velocity is. Because, not minus, minus, because, hang in there. Yeah, it's going down. Velocity is, the velocity is negative. It goes backwards. So it's going to be 8 inches minus 2 inches per second. It's going backward. First time, it's going forward, stays there. And then it's going to go backward. You can see that. Velocity is negative. So these you have to take care of. So it's going to be equal to 8 inches minus 2 inch underscore second times time minus 6, because you're measuring the time. When you multiply it by the velocity, it's going to be beyond the 6 seconds. Think about this thing, please. So it's going to be time, and this is a very common mistake, time minus 6 seconds, and the angle is going to be 720 degrees minus, because it's going, again, the propeller is going, turning backwards, okay, 90 degrees per second with a minus sign, okay, times time minus 6. We're almost done. So it's going to be 90 DEG underscore second times time minus 6 seconds. And always pray. You didn't miss the braces. Did I close the braces? Yeah, I think I did. I don't like to say okay. Invalid structure, line 9. Let me just see. Where's line 9, by the way? 1, 2, 3, 4, 5, 6, 7, 8, 9. 6 second, angle equal to 720 times time minus 6. Okay, so this seems to be okay to me, but am I missing something? Is there something obvious that you guys can see? Eight inches minus 2 inches per second times time minus 6. Angle equal to 720 degrees minus 90 degrees per second times time minus 6. Okay. I don't see anything obvious there. Okay, folks, I'm going to, obviously I screwed up for you guys here, but I have to repeat this thing in an hour, so I'll sort it out. Only the last part, this part, which is the critical part for us, okay, which I couldn't finish, okay? So let me find out what I did. I'm going to go through this. There must be something wrong. Something in the syntax I wrote is not correct. Everything else, keywords, let's check the keywords here. Else looks okay. I don't see anything obvious that's wrong. Oh, braces, 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 here, right there, braces. All right, I'll stop. I'll stop. Must be something else.